This actually will be a fairy tale, so take it with a grain of salt. Long, long ago, in a galaxy far, far away, a lowly software engineer named Irina came up with a social networking website idea she thought was really cute and sweet and cool, compliments as a service. And she called her imaginary social networking website Kudos. She imagined millions and millions of users flocking to her amazing website. Who wouldn't want to give compliments that everyone? Oh, I think I can make myself a little louder. Who wouldn't want to give? Who wouldn't want to give compliments that everyone can see online, and who wouldn't want to receive compliments that everyone can see online? Collect compliments, send compliments as birthday gifts. Yes, millions and millions of users. But back to reality, Kudos, the website, was yet to be created. Irina, a backend Java engineer at the time, was already working at a company serving hundreds of millions of online users. To her, a backend Java engineer, that's what Kudos really looked like. Her very own Java web server. So scary. She knew what it takes to create and support a busy web server written in Java, one of the most popular languages of our time. A Java server is a monolith. And by the end of this presentation, you will see what I mean. Something unpredicted happens and the whole thing collapses. You have to be very careful dealing with exceptions and errors in your code, or before you know it, the server goes down and you lose clients and money. Of course, in the course of a couple of years, most of the bugs and pitfalls and whatnot were more or less sorted out, but it was a long and thorny journey and actually very costly journey. But let's not jump too far ahead of ourselves. Luckily, the place where Irina worked at the time already had a well-established business model, steady cash flow, and a solid client base, so they could lose, a few $1,000s here and there. It was not a problem. But for her, it was a completely different story. And also in her company, they could afford to hire very experienced developers that could actually deal with all the complications that Java presents in the context of a busy web server. So back to Irina. Irina, who was trying to start a website while already working for a startup company, faced two serious limitations as old as money. Time. She needed time to develop the Kudos software, and money. She needed money to buy the hardware or get the hardware she would run the software on. So let's talk about money first. I know time equals money, kind of like E equals MC squared. Anyone try turning math into energy here? It's not trivial. Similarly, turning time into, your personal time into money is really not trivial. To start a company, you actually need money before you turn time into money. So very simply put, to host a website, you need hardware, you need CPU and memory to process and serve the web requests, and a database to save your data. And the more efficiently your web server uses these resources, the cheaper it will be for you. Well, modern-day startups actually have a great advantage. We can run our server in the cloud, so you don't have to buy that hardware up front. But anyone here tried registering for Amazon free tier? To do that, you have to take out your own credit card out of your own pocket. Just think about it for a second. It's nothing like your infinite corporate credits. So basically, we want our server to be very cost efficient for us, right? So also the other consideration, as our web server grows in popularity, we'll have to be throwing more hardware at it. And we really want to have, we want to have choices. We want to be able to play with what's the most cost efficient, what's the best for us. And to do that, we need really scalable software. we don't want to wait for our web server to actually grow before we start thinking about it. We want scalability to be baked into our server from day one. So basically, like I said, that way you could make the most efficient choice for your for your hardware architecture. And another great benefit of scalable, efficient software is performance. When we talk about performance, actually its nemesis, the premature optimization discussion, always comes up. But when it comes to web server performance, I don't even think it's a worthy discussion. Like, anyone here enjoys waiting for a web page to load? No? Nobody. My favorite example is like all these shoes I haven't bought because the checkout page took forever to load. I actually remember that, hey, I don't have room for shoes in my house anymore. So, but if this is not it's not very convincing, I'm sure that. So if you want some real statistics and science behind this statement, you can just Google this. And you'll get a lot of statistics about how page loading time affects how page loading time affects user sustainability on your website. If that's the right way to say it. So now let's talk about time. Not space time and not CPU time, Irina's personal time. She needed time to write her server software. Not only perfectly fast, efficient, robust backend, but also a fast and good-looking web frontend. And she really needed at least the Kudos website prototype to even get the angel investors or her programming friends interested in helping her out. So Irina knew that this Kudos business will be very hard. But seriously, everything is hard. Making a lasagna is hard. But one goes to a grocery store and buys this, and making a lasagna becomes a reality even for a stay-at-work mom. Modern-day cooks have lots and lots of great abstractions sold to them at the grocery store. Buying this, we buy time and knowledge and experience in a jar. But today, I don't think the software abstractions, and I'm talking about all sorts of abstractions, frameworks, high-level languages, even design patterns, are as far ahead as cooking abstractions. They exist, but the software jar is so much more likely to explode into your face. Besides, software abstractions sometimes are so hard to learn and figure out how to use for your specific case that in the end you think, it would have been easier and more beneficial if I just wrote the whole thing in C, cooking equivalent of from scratch. So a lot of developers get so frustrated with framework and third-party libraries and with new, arguably better languages that sometimes they get themselves into so much trouble using them that they decide to never use one again. Nonetheless, striving for abstractions is in the nature of all intelligent progress. We can't be constantly reinventing the same stuff. We have to move on. And so the new software abstractions get created all the time. Some very powerful, useful, and reliable. Some are very easy to learn, and some address very specific problem domain. Some are born in such favorable conditions where no better alternative existed that they gain popularity completely disproportional to their actual value, maybe due to some sort of a snowball effect. So some abstractions take us 2 steps forward, some take us 1 step back. Unfortunately, survival is not always determined by the software engineers. Very often, high-level managers and people with power and recruiters, basically people who don't know much about software, make these very important software decisions, and they get this snowball rolling and helping out mediocre or downright useless abstractions gain popularity. And software engineers just follow along. And I wish they didn't. Well, on the other hand, we can't expect all software professionals to starve themselves out of a principle. So maybe we can help out recruiters out, and when they send us an email, something like, was the description like this? Just think about it for a second. Maybe instead of just That's the kind of stuff I get like I get spammed with. This is like very typical of what I get in the email, like spammy emails from recruiters. So instead of sending this straight to the trash can, maybe we should call them back and say, hey, you know, it's 2015, and it's very, very hard to find software engineers who are passionate about Java and passionate about concurrent programming. In fact, you shouldn't be able to find too many developers passionate about concurrent programming this day, and you'll see what I mean in just a second. Well, so trying to stay positive here. I'm really curious what abstractions will be in about 10, 20 years, maybe even less. Maybe we'll have them so powerful kids will be able to build complex distributed architectures with some cute visual app on their iPhone 26s, or whatever the unimaginable holographic display gadget they'll be playing with. Or actually, let's dream bigger. Maybe we'll live in a world with a strong divide between software companies and companies that need to use software to build their business. The former will focus on solving the software challenges, and the latter will be creating elegant business solutions using software tools out of the box. Right now, we pretty much live in a universe of jacks of all trades, half-baked software solutions, and half-baked business solutions. And if you disagree with me and you can actually present me with some examples where it's actually not true, and I'll say, sure, I agree. Your example belongs to maybe the 15% of our universe that's not that horrible. But the other 85% are still there. So for me, this was just basically wishful thinking. But then very recently, I ran into this really mind-blowing talk by Peter Alvaro. I see what you mean. And he had, I don't know if anyone went to Strange Loop, and he actually doesn't, this is not wishful thinking. He actually, there is actually research and real ideas behind this sort of like a dream that I had. So I was really mind blown, and I strongly recommend that you watch his presentation if you have half an hour. So anyway, so dear software engineers, if we want a great future for our industry, let's be picky and choosy and stop following buzzwords so easily. And now let's look at Irina's example again. Obviously, she was picky and choosy because she had no choice. And it's still, I think, a good example. So she didn't consider Java. It was the language that fed her and her family for many years, but when it came to using it for her own web server, thanks, but no thanks, even though she knew it pretty well. So as I mentioned earlier, we needed highly scalable, parallelized web server. So what about Java concurrency package? Why not use Java concurrency package? Well, because it does not protect the developer from the perils of concurrent programming. If anything, it makes concurrency look deceptively easy and more appealing, but not any less dangerous. So for anyone here who actually haven't done concurrent programming in a while or haven't done it ever at all, I strongly recommend that you play with it, like use C or C++. Definitely try Java concurrency package and play with it long enough to realize you don't want to be doing this alone in the wild. Human brain is not designed to operate concurrently. So that's why experienced programmers who actually done a lot of concurrent programming want to avoid it altogether. We don't want tools that will help us do concurrent programming. We just don't want to do it at all. And there are quite a few programming languages out there that really take the concurrent programming away from the developer's plate. We'll look at a few of them in just a moment, but before we do, let's take a look at some very important considerations which will help us make our choice. So mutability and shared state are a really big enemy of concurrency. Well, just trust me on that for now, and I strongly recommend that you Google it later. And I'm actually surprised that the Google developers didn't do it before declaring Go to be a great concurrency abstraction. A program written in a language that allows mutable variables we'll inevitably end up with a deep down broken concurrency model. And the dangerous part is these problems might manifest themselves in a very obscure way, and you might not realize it is your concurrency model that's broken, but that will really cost you in the end. And remember, we are building our own web server with our own resources. So you can, of course, one of the arguments I hear is that you can always enforce immutability in your program, even if you're using a mutable language. Well, it's just, no matter how hard you try, like one day you go out drinking on Friday night and then come back coding, and you end up with, or maybe you use some third-party library, you'll end up with mutable state, shared state in your program somewhere, if it's not inherently immutable. And even if you do, it's still very, very hard work. And in case you haven't gotten the gist of this presentation yet, it's all about, it's something we try to avoid. And next, very, very important thing to consider is fault tolerance. We want our server to be up and running in all sorts of circumstances we didn't account for. We can't think about everything up front. And we don't want to lose money if we don't either. So we want our server up and running despite bugs and unexpected types of requests. So we don't ever want it to be down, and we want it to be handling the requests so we don't lose clients and money. And in my mind, the biggest enemy of fault tolerance is a monolithic structure of any kind. And we will actually be looking at a very specific monolithic structure. It's called Java Virtual Machine. So JVM has a monolithic heap that's shared between all the threads. And because of that, you can't kill bad thread or any thread in running on the JVM. It is not allowed. There actually was a method to do that in very early Java versions, but they realized that it's a very dangerous method. It can corrupt your heap. So you just cannot do that. And as a result, a bad thread has a serious potential of taking your entire server down. Basically, with all the good threads, handling all the good requests with it. Another side effect of it is monolithic garbage collector. So naturally, we end up with monolithic garbage collector collecting the garbage in the monolithic JVM heap. So with this guy around, we can experience long garbage collection pauses during which you'll be losing thousands of dollars in clients. And yes, Java garbage collector can be fine-tuned to death. So it's not going to be causing garbage collection pauses. But it's, again, very hard work. You'll have to hire very good, smart, experienced engineers to do this properly. And we, with our little startup, cannot afford it. So what can I say? Unfortunately, JVM was not created with multi-core CPU in mind. So we want our server to look maybe something like this. Small isolated processes with their own heaps. And if one of them goes nuts, we can just kill it, and the rest of them are running happily alone. So now the fun part. Let's look at the concurrency abstractions and see how, and choose one good one among them. So there's, before we talk about languages, there are actually concurrency models they actually are pretty surprisingly old. The Actor model was designed by Carl Hewitt in 1973, and communicating sequential processes by Tony Hoare invented in 1978. So here are some languages that implement these models. So Google language Go, and there's Clojure has core async package that implements CSP, and I just discovered Java has a library, a CSP library. I actually haven't seen it before. I think it's pretty new. Then we have Akka and Scala. Scala is immutable language, and Akka and Scala actually are very similar to Erlang, but they were done to play nicely with Java ecosystem. So let's take a look at each one of these languages. So Go is a mutable language. Does it fit our requirements for web server, which we discussed? We want immutable language, and we want fault tolerance and mutability. So Go is a mutable language. So Go is no Go. Clojure, it's an awesome functional language. I heard a lot of great stuff about it, but it's a language for JVM. So JVM, we just discussed, doesn't work for us. Java CSP, also obviously JVM. Akka and Scala, so also JVM. Also a note about Scala, it's a immutable language, but it's actually designed to work together with Java. So like, here's the like what even the point, because you'll be integrating it with Java, and it has all these mutable variables, so it doesn't work for us. Erlang. Back in 2011, Irina became aware of a rare treasure that had actor model implemented and concurrency beautifully abstracted away from the developer. Its variables 100% mutable and hence 100% safe for concurrency. It offers complete process isolation with each process holding its own heap and hence ability to kill a bad process programmatically. With it came another great abstraction, Open Telecom platform, offering common behaviors like server out of the box. The treasure was battle-proof in many a production environment, demonstrating 9 nines of uptime and in some cases years of uptime. For Irina, it was very good news because it meant her CUDA's backend could be created without investing into expensive developer resources, and it can be CPU efficient, and it can be run with minimal human support because Erlang has built-in supervisors, and they have the power to kill and restart misbehaving processes in a fully programmable way. For Irina, who I have to mention was a very lazy person and liked to sleep at night, it was purely priceless. Powerhouse of really useful abstractions created by 50 or so and brilliant Elixir employees over the course of 5 years. Perfectly suitable for her busy web server, and just like the stars in the sky, absolutely free. And unlike the stars in the sky, readily available for download. One more important bit of Erlang awesomeness is that it also contributes to Erlang fault tolerance. It's preemptive scheduling. I believe it's like actually, I think it's the only language, but I might be very wrong here, that actually has it, at least among well-established languages. It's pretty priceless, I think, especially in the context of our web server. So let's say, here's an example. Let's say we have a nasty infinite loop hidden in our code somewhere that we somehow missed during our normal course of testing. Granted, we have numerous processes running in our servers. Let's say we have one process per web request. And we actually did perform our testing. Most likely, this infinite loop happens under very rare circumstances. So only very few request types will actually end up with that unfortunate situation. If this happened in Java, as many requests of this type happen as there are CPU cores, our server degrades extremely fast and goes down. If this is written in Erlang, what happens is that every process that, even if it runs in an infinite loop, will be preempted after 2,000 or 1,000 reduction. I actually forgot, I don't remember exactly, but it's actually being placed at the end of the scheduler queue. So that way, the infinite loop will not ever eat our entire CPU core like it would in most other languages. With this scenario, there is definitely plenty of time for developers to wake up, take a look at their monitoring tools, notice that, hey, some of the requests are actually not making it, and fix the code and basically gradually restart all the servers, or maybe even take advantage of Erlang hot code swapping. So basically your server goes down very, very gracefully, if at all. You actually might, just think about it, it's amazing. Your Erlang server can run with an infinite loop in the code somewhere provided it's a very obscure, rare kind of situation, and it's hard to get into. But with that condition, your Erlang web server can actually run for months or, I don't know, for a while without degrading. However, to be fair, I have to warn you that Erlang has its own monoliths. They're not as bad and so fundamental like JVM heap. There are ways around them, but you have to be aware of them so you won't be unpleasantly surprised. So Erlang monolith number 1 is a binary space. It's actually a good thing, but it could be a problem for it could be a bit of a problem if you're not aware of it. So any binaries larger than 64 bytes get allocated outside the process heap, and only a pointer to that memory space is kept in the process. But unfortunately, the binary space only gets garbage collected when like memory pressure kicks in, and that's about like when it's 90% full. So, and once that happens, it's not going to be a full suite. It's going to just progressively collect, and it's a good thing because you won't have a long GC pause because of that. But what actually happens sometimes is that it happens too late in the entire, like it can actually take your entire node down. So there are ways around it, like placing a call to Erlang garbage collect in the proper place at the proper time, like when binary memory is at a certain size. But you have to be aware of that. You have to be aware of that Erlang has its monoliths. And another one is atom table. That thing never gets garbage collected, and it's about 1 million atoms in size. And so you have to be careful not to create atoms dynamically by calling like list to atom or something like that. Use list to existing atom instead. But let's back to the positive things about Erlang. Erlang is a functional language. That's great. And in case some of you software engineers out there haven't noticed, our world is slowly but surely is gravitating towards functional languages, finally. Well, since the time of self-Democritus, the scientists and philosophers have been discovering smaller and smaller basic particles that the vast diversity of our world is made of. Yet they keep looking to possibly discover the one and only. And today's quantum physicists are striving to describe all fundamental forces and the relationships between the elementary particles in terms of a single theoretical framework. It's known as unified field theory. So best of luck to you, quantum physicists. Software scientists, however, already discovered their unified field theory a long time ago. Functions are our fundamental forces. And here is a brilliant proof. I found it on Twitter. And for a while, I just thought it was a Twitter folklore. But then I decided it's not fair. Maybe I should find the source. And I did. And this is a slide from Scott Flashin's wonderful presentation of functional programming design. And we will be comparing some object-oriented pattern principles to functional programming patterns and principles. So here we go. Single responsibility principle, functional equivalent functions. Open-close principle, functions. Interface segregation principle, functions. Factory pattern, yes, functions. Dependency inversion principle, functions also. Strategy pattern, oh my, functions again. So that's Scott Flashin's invention. And he actually meant it as a joke. But to be honest with you, to me, a person who developed an object-oriented language for many, many years, it's no joke. It's actually kind of sad that we are just kind of coming out of the dark ages, even though functional programming was invented a long, long time ago. So I really hope we all come out of the dark ages soon. A little historical perspective. Functional languages were too slow back in the days when hardware was only a fraction of modern hardware power. So imperative languages naturally took over at that time, just because they were faster. But imperative languages proliferation was really it had purely a historical reason. So that no longer hold true. So if anyone doubts that the future of programming is functional, let's look at Java 8. This very popular object-oriented dude is now wearing a functional hat with its latest Lambda expressions. So I guess it knows that it's the only way to survive in the modern jungle. So back to Erlang. So to Erlang and Kudos. So with Erlang in mind, Kudos' idea started looking much, much more approachable. Something like this, probably. But if we look closer, for someone who never created an entire website before, it would have to begin with smaller parts, with something like that. And that seemed just a little trickier to Irina. Like I said, she just wanted to implement her idea without putting a whole lot of time and resources in. So she realized she needed a powerful web framework. And she needed a lot of common web functionality out of the box in her particular situation. So Kudos would be possible if she had a powerful language and a powerful framework. So it would look something like this. She definitely had resources to build something like that. So off to a search for a proper web framework. Back in the day, back in like 2011, if you ask around about good web framework, you hear Ruby on Rails. So she heard that Ruby on Rails would get a web server up and running in a matter of weeks, and Ruby developers were actually very happy with it. They really loved it. It was a powerful, extendable. It had built-in metaprogramming, maintainable, very, very pleasant language. One caveat: it's very, very slow. Well, Irina was expecting her website to become very popular, and she couldn't tolerate a very slow. She couldn't tolerate a language that was very slow. So eventually, with Ruby, when your web server gets very popular, you rewrite those slow bits in like C or Java or C++ or maybe Erlang. But the idea of rewriting the bits of her web server when it becomes popular was just not tolerable. It actually sounded quite ridiculous. My server is becoming popular, and now I have to, instead of enjoying it, I actually have to rewrite half of my software. Well, thank you, but thank you, but thank you. Next choice was PHP. That guy was supposedly a little faster than Ruby on Rails, and it had a lot of web functionality out of the box. But so it wasn't slow compared to Ruby on Rails. But from what she heard, it could be a maintenance nightmare. That's probably the most likely reason why a lot of PHP developers switched to Ruby on Rails and are loving it. So maintenance nightmare. Thanks, but no thanks. If you expect your web site to fail, who cares if it's maintainable? Irina really expected Kudos to succeed. Why else would she bother with it to begin with? So anyway, this kind of decision-making was happening long, long ago, back in 2011. It was a very imperfect world back then, and guess what happened to Kudos? Well, kind of nothing. Trying to choose a perfect language and web framework combo was like sleeping with a short blanket. When you cover your head, your feet get cold, and when you cover your feet, that's actually, I'm quoting Joseph Alim on CSS, and I found this quote on Twitter. That's where I find most of my information. Well, now it is 2015, and we live in a much better world. Joseph Alim didn't just come up with this awesome quote. He actually also created Elixir programming language. And built on top of Erlang millennium and Erlang OTP, it has beautiful hybrid Ruby Erlang-like syntax, and thus appeals to a number of Ruby and Erlang developers, and has naturally all the benefits of Erlang that we discussed, including complete interoperability with Erlang code and libraries. and onto the cherry on top. Chris McCord built a fully featured web framework in Elixir. It doesn't sacrifice speed like Ruby on Rails or maintainability like PHP. And ultimately standing on the shoulders of giants, the Erlang VM and Erlang OTP, it offers amazing scalability and fault tolerance for our web server. So the name of the framework is Phoenix. And this time around, we got it all. Call it the best of both worlds, or call it a perfectly sized blanket. And this time around, Kudos has a chance. This concludes my presentation. Please let me know if you have any questions. Any questions?
Can't be this many people.
Also like criticism and arguments and stuff.
So is that the end of the story, or is Kudos? You've ended your story early. Is Kudos succeeding, or?
No, actually, it only has a chance now that I found the perfect web framework, and
so
now we have all the
look out for
perfect
season
tools.
2, yeah?
Pardon me?
Look out for season 2, as the story continues.
Possibly. Though so far I did create some RESTful services with Phoenix and Elixir. It was a very pleasant experience.
Questions? Thank you very much.
Thank you very much for your attention.